I'm Blake, this is Liliaine, and this is Lars, and this is our design, the Pedestrian Utility Safety Headband. Basically, how this design works is it has the input, the photocell resistor, measures the amount of light in the area, and the LED panel and the microbit and the LED turn on when it gets dark to help protect pedestrians.
How we built and designed the Pedestrian Utility Safety Headband, also known as PUSH.
Okay, defining the problem. We were tasked with creating a safety device that kept pedestrians safe in the dark that applied to the following requirements. The device provides for a safer condition, the device is wearable, and the device can be activated by the wearer or an environmental condition. We chose this because it's important to solve. 50% of traffic deaths happen at night, and in 2020 alone, more than 42,000 people were killed.
We all knew that we wanted to make something that illuminated in the night and turn off during the day. From Liliaine, she wanted to make a wristband that would light up, and when you would move your wrist in the direction you wanted to go in, and it would illuminate it for you. Blake's idea was to make a fanny pack to be worn on the torso that would function as a bag and a safety measure. My idea was to make a hat to make you warm while having a light on it to show you where you were going. Developing a solution. We wanted to develop a solution for pedestrians' safety at night or in dark places. We chose this because of how we want to make it easier for pedestrians to see in the dark and feel safer when it starts getting darker earlier in the day.
Okay, generating concepts. These are the basic sketches that we made at the very beginning when we were brainstorming ideas. We ended up not going with any of these for several reasons, but these gave us ideas on how to execute the final design. We ended up, as I said, not choosing any of the options, and instead we tried to make a new innovation that took aspects from all the designs. Then we began creating a flowchart and sketches, which are shown in the next slide. And right here, you can see our flowchart. It's very simple, which is one of the pros of the device. It's like simple to wear and use. And then this is our decision matrix and where we all wrote our different ideas.
To find out if our prototype worked, we switched off the lights to let our photocell resistor record the value onto the microbit. We then recorded the value by taking note of it and did the exact same thing with the light on. And after both values were taken note of, we coded the LED to show to turn on when it's dark and then to turn off when it's light.
And this is our final sketch.
The headband works by the photocell resistor recording the light value, like I said, of the room or environment and sends the value to the microbit, which then decides either to turn on or stay off. The headband can only do this when powered by a battery, which can be hidden in the headband, keeping it comfortable for the pedestrian wearing it.
And this is kind of our timeline of how this worked. So our initial code is over there. They stayed the same because, as I said before, one of the pros of the design is it's very simple and easy. And then that's the wiring that we did, which we eventually hid in between two pieces of cardboard in our design.
Just the final prototype is basically what our headband can do. These two photos show our headband being off with Blake's hand covering the photocell resistor, and on when Blake's hand's covering the photocell resistor, and then off when nothing's covering it.
Reflection/evaluation. When we were building our headband, we had a few challenges, like the clips being too close together and messing up the light, and figuring out how to hide the wires in the reference and the headband so it didn't look so messy all the time. We could have decorated it more, made it more functional, but that might have made it harder to wear. We learned to wire things by combining the engineering design process, our microbit knowledge, and how to code our microbit, and then made sure it functioned properly.
Thank you for listening.
All right.